Today we're going to discuss indefinite integral. So let us start first with the definition. So let f of x be a differentiable function such that f prime of x equals f of x. Then f of x is called the primitive or antiderivative of the function f of x. And the expression f of x plus c is called a definite integral of f of x. So we write the indefinite integral as follows. So the integral of f of x dx equals f of x plus a constant. So below is the different parts of the expressions. So we have the integral sign followed by f of x, which is known as the integrand, and d of x is differential, is equal to the f of x, which means the primitive of f of x or antiderivative of f of x, plus c, which is the constant of integration. So the next slide, I just like to show to you the basic integration formulas. So we have here from 1 up to 18. So please be familiarized with the formulas of basic integration formulas. And for the next slide, so they are just the same, but I just like to emphasize here that for example, letter A, the integral of sine x dx is equal to negative cosine of x plus a constant. And for letter B, the only difference between the two formulas is that the angle for letter B is ax plus b, while the angle for formula A is only x, or having a coefficient of 1x. So in that sense, for formula letter B, we can have a shortcut formula by taking only the reciprocal of the coefficient of x. So therefore, the integral of sine ex plus b of dx is equal to the negative 1 over a cosine of ax plus b plus a constant. Or you can solve that one by using a substitution rule wherein you are going to let u is equal to ax plus b and then solve for du, and then the result for that will give you this answer of negative 1 over a cosine of ax plus b plus a constant. So letter C and letter D, they're almost similar. With the E and F are also similar. And for G and H, they're also similar to each other. For letter E, the first one is the reciprocal identity of 1 over cosine squared x that is equivalent to secant squared x. And the third one is also an identity from the Pythagorean identity, which says that the secant squared x is equal to the 1 plus tangent squared x dx. So these three equations is just the same as 2 tangent x plus a constant. So the antiderivative of the first three statements is equal to tangent x plus a constant. In similar manner with letter F and on letter H. Okay, so please be familiarized with the formulas so that you will easily apply the formula for the next examples. So let's start now with the computing indefinite integral. So what I failed to include the formulas here for the slide number 2 and 3 is that of the power rule. So it says that the integral of u raised to n du is equal to u raised to n plus 1 all over n plus 1 plus a constant, wherein n is not equal to negative 1. Now let's try to solve for number 1. Applying the power rule, so the integral of 4x cubed plus 3x minus 9 dx is equal to 4, this can be now 4x, then the power is 3 plus 1 all over 3 plus 1 plus 3x, 1 plus 1, we have 1 plus 1 over 1 plus 1 minus 9x, then plus a constant. By simplifying that one, this becomes 4x to the power of 4 over 4. So we cancel 4. So we can have now x raised to 4 plus 3x squared over 2 minus 9x plus a constant. Okay, for number 2, so we can write here below. So I can write now 5x, 3 plus 1 is 4 over 4 minus 10x to the power of negative 6 plus 1 is negative 5 over negative 5 plus 4x squared over 2 plus a constant. So by simplification, we can write now 5 over 4 of x raised to 4. Negative 10 divided by negative 5 will give you positive 2 over x raised to 5 plus 2x squared plus a constant. Or you can write in this way, in this form also, as 5 over 4 x raised to 4 plus 2x raised to negative 5 plus 2x squared plus a constant. For number 3, we have the integral of x plus the cube root of x times 4 minus x squared dx. So first of all, we are going to multiply the integrand. So using the FOIL method, the first term is x times 4. So we have the integral of 4x. Outer terms, we have negative x cubed. Inner terms plus 4 times the cube root of x. And last terms, we have the cube root of x times negative x squared will give us negative x raised to what is 1 plus 1/3 plus 2. So it gives us the exponent of 7 over 3. So over 7 over 3 dx. Okay, so after that, we are going now to integrate. So when we integrate, we are now going to remove the integral sign. So the first term, we have 4x squared over 2 minus x to the power of 4 over 4 plus, that is now 4 times 4 times x raised to the power of 1/3. So 1/3 plus 1, it gives us 4 over 3. So we can write now 4x raised to 4 over 3 all over 4 over 3 minus, so this is just 3 over 7 of x to the power of 7 over 3 plus a constant. So simplifying further, so this can be now 2x squared minus x raised to 4 over 4 plus 4 times 3/4 is equal to, so that is now 3x raised to 4 over 3 minus 3 over 7 of x raised to 7 over 3 plus a constant. So that is now the answer for number 3. For number 4, the given is in the integral of 4x raised to 10 minus 2x raised to 4 plus 15x squared over x cubed of dx. So in that case, we are going to simplify that first by dividing. So the quotient for this now will be equal to, we have 4x raised to 7 minus 2x plus 15 over x dx. So by integration now, we can have 4x raised to 8 over 8 minus 2x squared over 2 plus 15 of ln of the absolute value of x plus a constant. So we can still simplify further. So 4 over 8 means 1/2. So we have now 1/2 of x raised to 8 minus x squared plus 15 times ln of x plus a constant. Okay, for number 5, the integral of 3e raised to x plus 5 cosine x minus 10 secant squared x dx. So the first term will give us 3e raised to x plus the integral of 5 cosine x is 5 sine x, and the integral of negative 10 secant squared x dx will give us the negative 10 of tangent x plus a constant. And then for number 6, so the integral of 2 secant x tangent x plus 1 over 6x dx. So the first term is equivalent to, so the integral of the first term, so let's write first 2 as a constant multiplier. So we have 2 times the integral of secant x tangent x is secant x plus, we have a constant multiplier of 1 over 6, so 1 over 6, and the remaining term is dx over x. The integral of that will give you ln of x plus a constant. Therefore, the integral of 2 secant x tangent x plus 1 over 6x dx is equal to 2 secant x plus 1 over 6 ln of the absolute value of x plus a constant. So for number 7, we have the integral of 23 over x squared plus 1 plus 6 cosecant x cotangent x plus 9 over x dx. So the first term will give us the integration of 23 of arc tangent of x, okay, plus the second term will give us the integration of that is now the integral of cosecant x cotangent x give us negative. So therefore this, so that must be negative 6 cosecant x plus 9 ln of the absolute value of x plus a constant. So for number 8, so we have the integral of 7 minus 6 sine squared x over sine squared x dx. So first we are going to divide the given integrand. So therefore, it becomes now the integral of 7 over sine squared x dx minus 6 sine squared x divided by sine squared x will just give us now the integral of 6 dx. Or you can write that one as one integrand. So we can write here 7 over sine squared x minus 6 dx. So we can write now the integral of 7 over sine squared x minus 6 dx can be written as the integral of 7 cosecant squared x minus 6 of dx. Now let's take the integration of 7 cosecant squared x. It will give us the integration of the negative 7 of cotangent x minus 6x plus a constant. Okay, for number 9 and 10, so we have here, given the following information, determine the function of f of x. So number 9, f prime of x is equal to 4x cubed minus 9 plus 2 sine x plus 7e raised to x, and f of 0 is equal to 15. So first of all, we are going to solve that using this formula. We have f of x is equal to the integral of f prime of x dx. So by substitution, we can write now f of x is equal to the integral of 4x cubed minus 9 plus 2 sine x plus 7e raised to x dx. So taking the integration for this, it gives us x raised to 4 minus 9x minus 2 cosine of x plus 7e raised to x plus a constant. So now this is now our f of x. But since we have another given of f of 0 equals 15, so I can write now f of 0 is equal to 15. And then I will replace x by 0 from this equation. So following that one now, we have f of 0 is equal to 0 raised to 4 minus 9 times 0 minus 2 cosine of 0 plus 7e raised to 0 plus a constant. So we know that it's now equivalent to 15. So the right-hand side now will give us negative 2 plus 7 plus a constant. Therefore, solving for C, the value of C now will give us 10. Okay, so after solving C, now we are going to substitute the value of C from f of x. So finally, we have f of x now is equal to x raised to 4 minus 9x minus 2 cosine of x plus 7e raised to x plus 10. So that's now the answer of number 9. Now, let's move on to number 10. Okay, for number 10, the given is f double prime of x equals 15 square root of x plus 5x cubed plus 6. Then we have f of 1 equals negative 5 over 4 and f of 4 equals 404. So we are solving here for f of x. So first we're going to solve for f prime of x that is equal to the integral of f double prime of x dx. So by substitution, we have 15x raised to 1 half plus 5x cubed plus 6 of dx. So integrating this one, we have the integral of 15x raised to 1 half will give us 10x raised to 3 halves plus 5x raised to 4 over 4 plus 6x plus a constant. So that is now the value of f prime of x. Now next we have to solve for f of x. So that is equal to the integral of f prime of x dx. So by substitution, I just write 10x raised to 3 halves plus 5 over 4 of x raised to 4 plus 6x plus a constant of dx. So by integrating this one, so the integral of 10x raised to 3 halves will give us 4x raised to 5 halves plus we have 1/4 of x raised to 5 plus 3x squared plus cx plus d. So our new constant now is d because of the variable c dx in the f prime of x. So we have the variable c in the f prime of x. So therefore we have now, this is now the value of f of x. Since we have f of 1, so I can replace now x by 1. So we have f of 1 is equal to negative 5 over 4. So I can write here negative 5 over 4. And then replacing x now by 1 will give us 4 plus 1/4 plus 3 plus c plus d. So we have negative 5 over 4. So the right-hand side now will give us 29 over 4 plus c plus d. Or we have now c plus d is equal to negative, negative 17 over 2. And I will name this one as our equation number 1. So after we solve for f of 1, we have now c plus d equals negative 17 over 2. So to solve for f of 4, so f of 4 is equal to 404. So we have 404. So replace x now by 4. So it will give us 4 times 32 plus 1/4 of 1024 plus 3 times 16 plus 4c plus d. So by simplifying, so the right hand side will give us, so we have here 404 is equal to 432 plus 4c plus d. So we have to solve now for 4c plus d will give us now negative 28. And I will name this one now as equation number 2. So combining now the equation 1 and 2 will give us, so the first equation is C plus D equals negative 17 over 2. And equation number 2, we have 4C plus D is equal to negative 28. Okay, so if I decided to eliminate D, therefore I will subtract the two equations. So therefore, so by subtracting, so we can write here now minus, so we have now the negative 3C is equal to, so negative 17 over 2 minus negative 28, it gives us the difference of 39 over 2. And solve for C, that's why we have C now is equal to negative 13 over 2. Since we know already the one of the unknowns, so we can choose now either equation 1 or equation 2 to solve for the next variable. So solving for D, so I will choose now equation number 1. So I have C plus D equals negative 17 over 2. So D now is equal to negative 17 over 2 minus the value of C. We have negative 13 over 2. So the difference now, which is the value of D, will give us the answer of negative 2. So we have now D equals negative 2. So finally, we can now write the value of f of x. So therefore, f of x will be equal to 4x raised to 5 over 2 plus 1/4 of x raised to 5 plus 3x squared minus 13x over 2 minus 2. So that is now the answer of number 10. Okay, so I just checked from the given the equation of f of x. So we have 4x raised to 5 over 2 plus 1/4 of x raised to 5 plus 3x squared plus cx plus d. So I replace now the value of c and d. That is why we have now f of x equals 4x raised to 5 over 2 plus 1/4 of x raised to 5 plus 3x squared minus 13x over 2 minus 2. So that's all for today.